conservation can come from the idea of Newton's third law, which states that every action force there is an equal and opposite reaction force. An example of this type of collision is an elastic collision. An elastic collision states that when two objects collide, they move off with different momentum. Sorry. So, let's do an example of an elastic collision. Say we have a 500 kilogram car. We're going to label this mass of A, traveling 12 meters per second. So we know that the velocity of A is 12 meters per second. But we also have a 12,000 kilogram truck, which is going to be mass B. And we can see that this is traveling 3 meters per second. After the collision, the car is traveling 4 meters per second. We want to know what is the truck traveling after the collision. We need to find the final velocity of the truck. So, in order to do this, we need to know that in elastic collision, the equation you need to memorize is mass of A times the velocity initial of A plus the mass of B times the velocity initial of B is equal to the mass of A times the final of A plus the mass of B times the final of B. So, in order to solve this, we have 500 kilograms times 12 plus 12,000 kilograms times 3 equal to 500 times 4 plus 12,000 times x. X being the velocity of the truck after the collision. So we have to type into our calculator 500 times 12, and we get 6,000 plus 12,000 times 3, 36,000 equal to 500 times 4, 2,000 plus 12,000 x. Simplify the math. 6,000 plus 36,000 is 42,000 equal to 2,000 plus 12,000 x. Subtract the 2,000, subtract the 2,000, 40,000 is equal to 12,000 x. Divide by 12,000, divide by 12,000, and we know that x, the speed of the truck after the collision, is equal to 3.33 meters per second. Alright, the next type of collision we're going to do is an inelastic collision. An inelastic collision is when an objects collide and they move off together with the same velocity. Therefore, for inelastic, we have the mass of A times the initial of A velocity plus the mass of B times the initial B velocity equal to the mass of A plus the mass of B times the final together velocity. So, say we have a 500 kilogram truck traveling at 5 meters per second and a 700 kilogram truck traveling at 10 meters per second. We want to know, after they collide, what is the final velocity? Well, to solve this, we're going to say the first truck is going to go with the mass of A and the V of A, and the second truck is going to go with the mass of B and the V of B. So, mass A, 500 kilograms, times the velocity 5 meters per second, plus mass B, 700 kilograms, times the velocity of 10 meters per second, is equal to the two masses combined, 500 plus 700, 1,200, times VF, what we are trying to find. So, to simplify, 500 times 5, 2,500, 700 times 10, 7,000, is equal to 12,000 VF. 2,500 plus 7,000, 9,500 is equal to 1,200 VF. Divide by 1,200, divide by 1,200, and we see that the velocity of the final, both trucks together after the collision, is 7.92 meters per second. The last type of collision we have is an explosion collision. In an explosion collision, we can state that the total momentum before and after is equal to 0. Where we know that the mass of A times the V of A plus the mass of B times the V of B is equal to 0. So say we're given the mass of A is equal to 500 kilogram truck with a velocity of 5 meters per second. Mass of B is 250 kilogram truck. We need to know what is the velocity of B. Again, we just take it and plug it into our equation. 500 kilograms times 5 meters per second plus 250 times x, solving for the velocity of B, is equal to 0. 500 times 5, 2,500 plus 250x is equal to 0. Now we can say that minus 2,500 is equal to 250x. Divide by 250 divide by 250, we know that x is equal to 10 meters per second. X being the velocity of B. Now, since there is a negative, it could also mean that it's headed in a backwards direction, although the number stays the same, 10 meters per second. And that's the end of our video today on momentum and impulse.